Hi, everybody. Welcome to my second session for today. Super excited to be here. Still see some familiar faces from my first session, so apparently I didn't scare off everybody. That's good. During the next 40 minutes, something like that, we're going to dive deep into event-driven architectures. We're going to dive deep into microservice setup and AWS StepFunctions. And at the end, we're going to do a little demo. My name is Jimmy, and this is building a serverless event-driven Slackbot. Oops, sorry. So the agenda, some background into everything, background into microservices, event-driven architectures. We're going to do the deep dive into event-driven architectures and step functions. Then we're going to run into a demo, a pizza bot. So you that saw my first session, that was around barbecue. Yeah, we're still around the topic on food, of course. And then we're going to end everything with a summary and some conclusions. As I said, my name is Jimmy. I'm a father of 2 girls, which makes me afraid of nothing. I'm a serverless enthusiast, AWS ambassador, AWS community builder, and in my daytime job, I work as head of AWS technologies at Sigma Technology Cloud here in Malmö. So, some background. More and more teams today are building microservice infrastructure or microservice applications in the cloud. When we are building the microservice, we often do implement communications using a well-defined APIs. Often those APIs tend to be a RESTful API with synchronous invocations back and forth. And this works fine, but when we start to extend on our microservices, adding more and more services into the system, more and more services actually need to communicate with each other. We set up more and more communication paths, and these are tightly coupled, which means that the more the system evolves, there is a clear risk that our initial loosely coupled services become more and more tightly coupled. And that tends to become a problem as the communication path grows with our RESTful APIs. Throughout this talk, I'm going to use this use case, a pizzeria. It's run by 2 brothers, Mario and Luigi. They left the plumbing industry. There was no money in that. Went over to do pizzas instead. So that will be our entire use case today and what we're going to talk about. So the brothers started a pizzeria. People called in, ordered the pizza. They did the baking. People came to the pizzeria, picked up the pizza, and paid. All of the synchronous communication here between all of these parts. Then they figured out, this is going really good. Let's add some online ordering. So they started to build up some new microservices. So the user here places an order into our order service online that is picked up by the baking service, the brothers, that creates the pizza, and then you come and pick it up and pays. Quite straightforward, works perfectly. So the user calls in, then they need to figure out that, it doesn't scale. We still need to handle the payments and everything. We still have to hand out the pizza. We can't do as much baking as we want. Let's extend this. Let's introduce payment service, and let's introduce a delivery service. So they do that. The user still places the order with the order service, and then the order service does the communication with the payment service, the bake service, and the delivery service over RESTful APIs, setting everything up. This way we added some orchestration using an example here, AWS StepFunctions for the order service to know about all the other services. Now, what if we do have a downstream error? What if the payment service doesn't respond? What if the payment service returns an error? The problem here is then that the order service needs to take care of everything. It needs to take care of canceling the order, needs to take care of canceling delivery. It needs to coordinate and orchestrate everything there is to do. And it then needs to know about all other services. So a different scenario is when we have a different order cancellation. So the user comes again, orders a pizza online, and yeah, everything looks nice. Then the brother starts to bake the pizza, and they figured out that they ordered pineapple on the pizza. We do not put pineapple on the pizza. I'm willing to go to war for this. There's no fruit on pizza, okay? We can agree on that right now. So no fruit on pizza. And the brothers agree with me and say, hey, we don't do pineapple on pizza. Now they want to cancel the order. The bake service now need to do a cancellation of this order because they don't do it. So the bake service then need to know about the payment service. It needs to know about the delivery service. It needs to communicate with these services and cancel the order. And finally, it communicates to the order service saying, hey, I have canceled the order, and please communicate that back to the user. Here is where the communication path has grown. The services in our system now need to know about more and more services. And this is not something it's that interesting. And even worse, Luigi had a brilliant idea. He had added a loyalty service. So buy 10 pizzas, get the 11th one for free. And he didn't tell Mario, the bake service, about this. So when the order was canceled, the loyalty service didn't get that cancellation. It didn't know about that service. Which means that you got loyalty points for something that was canceled, which is not that good maybe. So that is some of the problems we can see when the microservice architecture grows and we need to have more and more services. How can we solve this in an event-driven architecture with Amazon EventBridge? First of all, what is an event? We need to figure out what is an event. An event is a signal in the system to indicate that something has changed or happened. Order created, order canceled, something like that. Something has happened in the system. Events are immutable, which means that once they are sent into the system, they are not changed. They are what they are. They are facts. Events are observable. I'm going to talk a bit about more what I mean with this event being as observable, and they are normally in JSON. It can be in XML if you want to go down that route, but mostly in JSON. So with observable, what I mean is that you have the producer here that sends an event into the Amazon EventBridge saying data has changed. Then it doesn't care anymore. I have to communicate the data has changed. Then other services in the system has registered to EventBridge and are observing these event data being changed. That is what I mean with an event being observable. That other services can view and look at these events and pick them up. So if we go back to our online ordering then, how would we build this in an event-driven architecture instead of having one service taking care of everything? Well, once again, the user, we can't do something about the user is still there, places the order with the order service, but now instead of the order service doing a lot of communication with other services, it just adds an event. It adds an event onto Amazon EventBridge saying, hey, order created. Then the payment service, loyalty service, bake service, and delivery service can pick up that an order is created, figure out, hey, there's a new order, I need to do something. We need to bake the pizza, we have to pay for the pizza, we have to deliver a pizza. So that event is just broadcasted out and observed by all other services. So once again, if we have this no pineapple use case, how do we do that then? Because now we need to communicate once again to the different services. Right? So what happens is that the bake service puts an event onto Amazon EventBridge saying, hey, order canceled. We don't put pineapple on pizza. And then that event can be distributed to all other services that are interested and are observing this event. And the order service, which is our front gate to the user, can communicate back. Now, if you want to extend on this, let's say Luigi had one more great idea. he wants to add a tracking service to figure out what is our most popular pizza. Then extending on this is fairly easy. You create a new service, a tracking service, and you add that as a rule onto Amazon EventBridge. Now you're also observing order created. And if we cancel it, it is also observing order cancelled. Meaning that extension is easy, each team can run on its own and operate on its own. Of course, there need to be some form of event registry. Since if you're going to start observing event created, you need to figure out that there is actually an event in your system called event created or event cancelled. And that is why you build up an event registry, and that you can use the services from AWS on Amazon EventBridge to actually do this, have this event registry. That becomes your API. But your services keep being loosely coupled as they don't need to know about each other. So, quick summary on event-driven architectures. Actions, signals are being observed. Services are loosely coupled and are easy to extend. Now, we're going to do a deep dive on two of the services before we move over to doing a demo. We're going to look at Amazon EventBridge and Amazon StepFunctions. So what is Amazon EventBridge? I've been talking a lot about it. What is it? It's a fully managed and serverless event bus, meaning you can put on your messages and the messages are distributed. It has 15 plus. I use a plus because I'm never trusting AWS to put a fixed number on something, because every time I do that, they will release something new. So 15 plus services as target for Amazon EventBridge. What's also really good is it has support for API destinations, meaning if you have an API already, you could have it running on premise if you like. Amazon EventBridge can call that API. It can do EventBridge to EventBridge communication, meaning that you can actually put event bridges in or event buses in each of your own microservice and then distribute between different event buses. It makes it super easy to build an event-driven architecture. You don't have to take care of scaling. You don't have to take care of provisioning any pub sub servers or anything like that. And it comes with a super low price. You pay per event being sent in or rule being executed. When we're talking about EventBridge and event buses, we are basically talking about two different event patterns that I want to go into. We're using a single bus, which becomes a centralized bus pattern, and we have a multi-bus decentralized pattern. In the centralized pattern, we actually have one single event bus that all our services communicate to and with. It makes a central routing, which becomes very easy to handle, and it's very easy to integrate new applications since you have one place to do that. The drawbacks of this is you have a single point of failure. Of course, you have one event bus, a single point of failure, and you can have some leaking business logic. So the problem would be if a microservice wanted to communicate internally over an event bus and you only have a central bus, that business logic can leak out into the other services. I would say that the single bus pattern is a good place to start if you want to start in building an event-driven architecture. It's way easier to manage than in decentralized. So this is basically what I've been talking about when I talk about centralized event bus. So you have a central event bus here, and all of my three services has connected onto that and using that single service as the event router. Meaning if an order service wants to start observing something new, it creates a rule on this single bus. In a decentralized system, we create one event bus in each microservice. And other services that want to communicate or listen to events from that microservice need to connect to that microservice event bus. There is a picture coming up. I will explain it. But the advantages with this is you don't have a single point of failure anymore. You have distributed your events over several event buses. It enables autonomy, since the teams are now fully responsible. The microservice and the team owns the event bus as well, so fully autonomous. The disadvantage is it is a challenge to design. This is a super distributed system, and everyone that has been designing a distributed system knows all the challenges there are with building and designing a distributed system. And there are more resources to manage, which can take time. So in a multi-bus pattern, each service has its own bus, and there is no centrally managed routing. So this is what I've been talking about. So the order service, the delivery service, and the bake service all have their own event buses. And if the bake service want to have some information about the order service, it need to connect to that order service event bus. Now, adding more and more services into this, you can see that the problem then tend to leak, that you have starting to coupling things again. The one benefit of this is when you're running a multi-account strategy in AWS, it becomes fairly more easy to do this setup instead of having one single bus. That would be a bit of a mess. When you build using Amazon EventBridge, each account in each region comes with a default event bus. This default event bus is used by the AWS services to communicate. So if an EC2 instance spins up, an event is added to this default event bus saying, hey, an EC2 instance has started, it has stopped, I have created a Lambda function, something like that. Everything that happens in your account, most get communicated onto this default event bus. An object is created in S3, it's added onto this event bus. Can you use this default bus when you build your own application? Yes, of course you can do that. I, however, recommend that you don't. I recommend that you create your own custom bus for your application. Leave the default event bus to Amazon services, let them use that, you have then a clear separation of data and duties. It's the same reason we don't use a default VPC in Amazon, because it's not good. So my recommendation, create your own custom buses. Remember that. Also, create subscriptions. What do I mean with subscriptions? Rule in Amazon EventBridge can have up to 5 targets. This is a hard limit. You can't go over 5. 5 is a max. You can't raise that limit. There is 5. So if you create an event filter on an event and then have multiple targets, you have created a coupling on the filter. It will be very complex to add more targets, because what happens if you reach the 5? Now I need to create a new rule and start adding targets to that, and I need to keep that in mind that I have a new rule. And what if I remove one target? It will become a mess. And if you change the filter on the event, you change it for all of the targets. So with subscription, I say you create a one-to-one mapping. One event, one filter, one target. The coupling is now on the event, it's not on the filter. It's easy to add more targets. If you want to add a new target, you create a new event filter and you add that new target. You can just build out how many you want. Sure, you will have a lot of events and event filters in your system, but with infrastructure as code, you can handle that pretty easy. And if you need to change a filter, you only affect that target. You don't affect anyone else. So that's my recommendation. Create subscriptions. Then Amazon AWS StepFunctions. What is AWS StepFunctions? I've been talking about it a lot. It's a resilient workflow automation. So it will automate or calling your Lambda functions, calling your DynamoDB, doing things with S3, everything when you have dependency and you build up a dependency graph, what you need to do in a certain order. I need to fetch something from S3. I want to process that from S3. I want to add that information onto DynamoDB in that exact order. And then AWS StepFunctions can help you with that. It builds this up. And it comes with built-in error handling. So if something fails, you can have a catch state and do rollbacks. It has exponential backoff and retries and things like that. And it's very cost efficient. And it has some powerful service integrations. When we're talking about service integrations in AWS StepFunctions, we're talking about two different kinds. We have the optimized integrations. Optimized integration is for around, once again, 15 plus services that has been optimized and customized to do an integration with StepFunctions. Then we have SDK integrations, and that comes with over 200 integration points, and that is one of the latest releases, and probably one of the best releases in a very long time. And what we can do with that is basically we can actually call over 9,000 different APIs directly from StepFunction without writing a single line of code. That becomes super powerful. We have two different workflow types when we're talking about StepFunctions. We have the standard workflow, which is for long-running tasks. Basically, it can run up for 1 year. It has waits and things like that. So you can basically wait for a manual click. Let's say you have a delivery. So you wait for an order to be fulfilled, but you're out of stock. So then we could actually have a step function waiting here until we're back in stock, and the human says, okay, then everything continues. So we can have manual waits, and we can run this for up to 1 year. You pay per state transition. So if you have 10 states in your step functions, you pay for each transition into a new state. So having a wait that you wait for half a year, the customer probably has canceled the order, but you can wait for half a year. You don't pay nothing because you didn't do any state transition. We can start around 2,000 of these every second. These are a bit more heavy. And then on the other side, we have the express workflow. The express workflow is for short running things, up to 5 minutes maximum, then it's terminated. And we can do over 100,000 starts per second. For the express workflow, you pay per duration. So if a workflow takes 4 minutes to run, you pay for 4 minutes, meaning you don't want to do long waits because you pay for that. You want to do something quickly and you want to do it fast and efficiently. Then the express workflow is really good. You can have 2,000 different states in express workflow. You only pay for the runtime. Now, when we're talking about step function, it comes with some really interesting things that we need to talk about. First of all, intrinsic functions. Intrinsic functions is actually where we can do basic data manipulation on the events coming in without running any code. With the latest release, we have around 15 plus different functions. We can do array gets and string splits and string modification and things like that without writing any code of our own. We need to talk about the task. The task is a single unit of work. That is basically what everything is in a step function. Even if you run a service integration or an SDK integration, that is done in a task. The task is where you do your job. A choice state we have, that's a possibility for us to control a flow. So if we want to do ifs and if-else and things like that in our step function, we can do that without writing any code. We have choice state and we do the different path and we do different things. It has a catch-all, meaning a default path, so basically an else. So it always falls back to that. The pass state is basically dummy state. So what's happening is that the step function doesn't perform any work in the pass state. It just goes through, it passes through. You can do some simple data modification, use it intrinsic functions if you like, but you can't do some work calling Dynamo S3 or something like that. And this is really good to use because there are some states in a step function that doesn't support that you go to the end state, meaning that you finish everything off, because some states can't do that. So what you do is then go down to a pass state, and then the pass state just goes to the end. A wait is, we can wait, as it says, we wait for a number of seconds, wait until a timestamp has happened, and the wait time can actually be a variable in the event. So we can feed into the step function that you should wait for 5 seconds, 10 seconds, and so on. So that, with those said, that is basically what we're going to do. Now we're going to do a demo. We're going to build out an event-driven Slackbot here. I'm going to do it live. Basically, the most dangerous thing you can do, a live demo. But as I said, I'm afraid of nothing. So we're going to build on this pizzeria. So what are we building? So first of all, the Slack hook, as I call it, the Slack webhook. We need Slack calling API gateway, calling a Lambda function, calling EventBridge. That is already in place. I have already deployed that. I'm going to show you a bit about it, but that is basically already been set up. So Slack we will use a slash command, and Slack will post that onto to API gateway, and Lambda will be run. That Lambda is the only piece of code we're going to write today. Everything else we're going to do with no code. We also have a notification service. It's already in place, meaning that we feed information back to Slack. So I add a message onto EventBridge, and that's added onto Slack. So every time I have an arrow saying I go from EventBridge to Slack, this is basically what I'm doing. I have this notification service in between. This is what I'm going to build. I'm going to build on our order service. So the order service picks up our order, process it, add the message, store it in DynamoDB, and post the message back to EventBridge saying, hey, order created. That's one thing. The second thing we're going to do is going to build the bake service. So the bake service is going to pick up that an order has been created. It will fake baking the pizza. It will add a message onto Slack saying, hey, your pizza has been baked, blah, blah, blah. And then the delivery service that is also already in place will pick up and things like that. So that's it. Now we're going to go building. And I see if we can do this without breaking everything. What do you think? So, is it big enough, by the way? Could someone in the back tell me if I should need to zoom in more? Better? Thumbs up? OK, perfect. So here is my bot, pizza bot, I call it. I have already set it up. So I've set up a slash command that I call pizza order. So that is what we're going to do. And this pizza order has a request URL here, and that is basically to my API gateway that is already in place. So I've created this API gateway, and I have a method in this API gateway called Slack hook. So that is what Slack is going to call when I do this pizza order. Not doing that anymore. So moving over to Slack here, and here I have a Slack channel called pizza order. I've been running this demo a couple of times. I needed some way to clear the screen. Apparently, you can't do that in Slack, so I had to add a lot of .ts messages. And so this is where we're going to do some of the work to see. So if we today now would add a pizza, we place a pizza order, and this want to have my name. Who am I that I'm ordering? This is who I am. And I'm going to order, let's say, an Napoli pizza, something like that. Just the name of the pizza or a number of the pizza. I'm going to add that. Now, we had a communication to API gateway that picked up that we had done this, and with slash commands in Slack, you need to respond immediately. You have a couple of seconds, then you need to respond. You're building something asynchronously. So what I'm responding back to Slack here is saying, hello, we received your order for a Napoli pizza. Now, let's go build, because now the pizza doesn't get ordered, right? We're missing something. So let's move over. Oops, zoom in again to all of my accounts. I did this demo, this test before, and I actually didn't get any internet connections. So I was almost a bit scared. So what we're going to do, first of all, we're going to build our step function. So we move over to step functions. And we're going to create ourselves a new state machine. And I'm going to use design your workflow visually, which is a new thing in the console that can do. I'm going to use a standard workflow because that's easier to debug, actually. So I'm going to do that. So let's do it like this. So I end up with this pretty nice looking workflow. So first of all, we need to pick up some information that we got from the Slack hook. And what I'm going to do, I'm going to use a past state now. As I told you, in the past state, you don't do any work, but I can do some data manipulations. So I'm actually going to do that. I'm going to start with a past state. So I drag this here. Oops. And I'm going to give it the name. Get pizza details. And for the input, input in this, sorry, not the input. Yeah, transform. So in my input, I'm going to do some transformation. I'm going to pick up, because with the Slack webhook, I get the parameters. So what I do get is in an array, as you saw, I wrote my name and then the pizza. I get that in an array with 2 on position 0 and 1. So I'm going to need to pick up on that, and I need to create an order ID. So I'm cheating. You don't need to look at this because I'm afraid of some things. But so writing everything on scratch on stage might not be the good thing. I'm going to tell you exactly what I'm doing. Hopefully you can see it. Please let me know if you can't. So here I'm going to use an intrinsic function calling states UUID. So I generate the UUID that will be my order ID. So I generate this in this past state. I also use the array get item on position 0 and position 1. And I know I'm hard coding this, so it should be name pizza. So if I turn them around, you order something for pizza for me with my name. So I'm going to pick this up. So that's good. That's what we're going to do. And then we need to do it like that. And what I want to do next is I want to store this information in DynamoDB. So what we're going to use here is Dynamo put item. I'm going to add that into that. And I'm going to use an optimized integration type, since that's available for DynamoDB. I'm going to give it the name. Store order. I'm going to use this optimized part. And then I need to specify the table name, what item and data to store, and things like that. And once again, I'm a bit chicken. So let's pick it up, and I will explain exactly what we are pasting here. So we have a table name that I call PizzaBot table. I'm going to insert an item, and I have a primary key that is a string, and I'm going to use the variable name. Remember, that came from the past state. I did that in the past state. And I'm going to use a sort key and give it the value of the parameter that was called pizza. So I'm going to do that. And I'm actually going to do one more thing here. I'm going to go to the output. And I'm going to say add original. I'm going to say discard. Because what is happening is that when I do an integration, the service will respond back to me. So DynamoDB will send back a response to me according to the DynamoDB API. But I'm not really that interested in that part. I'm more interested in the data that I created in my past state. So what I'm doing here is I'm telling StepFunctions that, okay, you get some information from the DynamoDB state from DynamoDB. Ignore that, please. Just use what you got as an input to me. So that's what we're going to do. And finally, we need to put this on Amazon EventBridge. I'm going to put an event. Am I running out of time? Sorry. I need to speed up, I think. I've been talking too much. Put event order created. So, and then we're going to add the message onto this saying OK. So this is the message we're going to add. I'm going to explain it quickly. Hopefully you can see it. So we add an entry saying that the source is our PizzaBot. So this is coming from our main service called PizzaBot. We added the data as our detail. The detail type is called order created, and I'm putting this on my event bus called PizzaBot. So this is what I'm doing. Let's do next. And I get this state machine in JSON if I like to inspect it. Hopefully it still is correct. Click next, and we give it order state machine. We create a new role. Let Amazon do everything for me in the console, doing some ClickUps, and this will create my state machine. While that is creating, we need to also now figure out, okay, we have a state machine. Now it needs to be invoked. So what we need to do is move over to EventBridge, like this. I need to go to my rules, and here I'm using my custom bus called PizzaBot. I need to create myself a new rule. I create a rule called order created. No, sorry. I call it a new order, something like that. Yeah, whatever. And we're not going to rule. We rule with event pattern. Next. And the event source is a sample events. Nope. So here is when I add my event pattern, event source, EventBridge pattern, not partners. Oh, sorry. So here, no. Sorry, I'm all the way. Event source, AWS event. Other. So we have a custom pattern. Once again, I have that already figured out. Add that onto that. JSON is valid. Next, I'm going to call my, hopefully step function has been already been created. Yes, it was done. Perfect. Create a new role. Next, and create rule. So now we created a rule on a bus saying that when we get this order created, invoke this step function. Hopefully now, when we go back, this is created, we go here, go to that one. When I go back to Slack, say pizza order, Napoli, we should get an event saying, hello, your order for Napoli pizza has been created and assigned order ID. This is basically now the event on the event bus triggered the step function that we created. That step function picked up my name. It picked up the pizza that we ordered. It created this UUID that we have here. And it added the information back to the event bus saying, hey, order has been created. So that's it. But there's no pizza coming, right? We need to bake the pizza. So once again, we need to do some interesting things. We need to create a new step function. Once again, I use the standard workflow. I have 1 minute. I'm going to do this. And we need to go here, and we need to once again do a pass state, because I need to pick up some information like that. I call collect output. We're going to do some transformation. Here we're going to just pick up the data and event that came from the previous one. Next, what we want to do is we would like to add a choice date. We'll not have time to do that, unfortunately. So next, what we want to do is post. We want to do a wait. We want to do a wait state. We don't wait for so long. We wait for 3 seconds, not 53. God damn it. We wait for 3 seconds, which basically when we're baking the pizza, we have a super oven. And then we want to post onto EventBridge. EventBridge, like that. I'm using the optimized integration point again. We're going to add that the pizza has been baked, and there's some order information, and we put it on the pizza bot. We say next, and we call it bake. And we say create. And while this is, oh, that was quick. Then we need to add an event one more time, since we need to know that the bake service has actually picked up on the order created. I call it bake rule. I'm adding that. Here I'm saying that the bake service need to listen for the order created event from PizzaBot. So next, and we target StepFunctions again, and the state is bake. Next, and great. So what is happening now? We post from Slack, pizza order, adds to EventBridge. The order service picks up that there is something coming in, creates the order, posts back onto EventBridge saying, hey, order has been created. The bake service picks up that the order has been created, bakes the pizza, and then will communicate back that the pizza has been created. Or baked, sorry, not created, baked. So, brave as I am, we move over to here. Sorry, that one, that tab. We say pizza order for me, and we create an app. Now we can say something else, so you don't see me cheating. Margarita, not sure if I'm spelling it right. We get that. We find information saying that the order has been created, and 1, 2, 3, your Margarita pizza has been baked and is ready for delivery, and it has been delivered to your doorstep. Everything running in EventBridge. Hey. So that was a demo. It was way quicker than I was hoping for. Let's see, I have 2 more slides. Please bear with me. Just a quick summary. What we have seen is how to build an serverless and event-driven architecture using Slack and no code. You remember we wrote single line of code in this demo. Thank you.